Hello everybody. In today's lesson 11.3, our topic is measure and draw angles. And our essential question in this lesson is, how can we use a protractor to measure and draw angles? So we will need a protractor for this lesson. Okay, it's a tool to help measure angles, and it can be read. It has two different scales, one that's read clockwise and one that's read counterclockwise. How it's positioned on the angle will let you know which scale you're going to be reading. And so we'll practice that as we go through. All right. And so the scale goes from 0 to 180. All right. So Emma wants to make a clay sculpture of her daughter as she appears in the photo from her dance recital. How can she measure angle DCE, or the angle formed by her daughter's arms? So angle DCE. So that would be the angle we're measuring. And so it goes on to say a protractor is a tool for measuring the size of an angle. So measure angle DCE using a protractor. So these are the steps for using a protractor. Okay, on our protractor, there's a middle point right here. Okay, and we're going to call that the center point. Okay, the little circle here. Okay. All right, so the center point of the protractor on vertex C of the angle. Okay, so we find the vertex here. This is what they're showing you. Okay, we put our center of our circle, our center point, right on the line. On the dot or the vertex, the corner of the angle. Okay, and then it says align the mark on the scale of the protractor with ray CE. One of the rays has to be lined up with 0. Okay, so that part is actually up to you, how you decide to do that, unless the angle shows you which way it's being measured or opens. Okay, so in other words, you see that I turned it this way, and on this one, it still lines up with 0. Okay, but we'd be opening the angle clockwise. All right, now, one thing I like to do sometimes when I'm measuring angles with a protractor is extend the line out. It makes it easier to see where it crosses the protractor. Okay, so step 2, line up the 0. There are lines on your protractor right here that help you line your protractor up with the ray of your angle. So I'm going to be lining this part up with CE on the angle. I put my center point on the vertex, line my ray CE with 0 on the protractor. Okay. And now it says find where ray CD intersects the same scale. Now, what they mean by same scale is where is your protractor lined up with 0? Okay. This is 0 on this side. So I'm going to be reading the inside scale. If the angle was going this way and my 0 was here, then I'd use the outside angle. Okay. So it's important that you recognize where you're lining up 0. All right. So where does it cross the protractor? Well, you can what we call eyeball it, right, and say, that's about 120. Okay. If you extended the ray out, you'll see that it is at 120. Okay, so the measure of angle DCE is 120 degrees. So the angle formed by her daughter's arms is 120 degrees. Now, we need to ask ourselves, does that make sense? Well, 120 degrees, that's greater than a right angle, right? And is less than 180, which would be a straight angle. So is this angle an obtuse angle? Is it greater than a right angle, but less than a straight angle or 180 degrees? It is. This is an obtuse angle, so that does make sense. If it was 90 degrees, it would be going through it right there. So it is greater than 90, but it is less than 180, a straight line. All right, so let's look at page 450. All right, we can also use a protractor to draw an angle of a given measure. And so it wants us to draw angle KLM with a measure of 82 degrees. Okay, again, we need our protractor. Use the straight edge of the protractor to draw and label ray LM. Okay, so all right, so that's going to be the 0 on my angle. Okay, the ray LM. Now place the center point of the protractor on point L and make sure you align LM with a 0 mark on the protractor. Then using the same scale from the 0, mark a point at 82 degrees and label that point K. So this is what they're asking us to do. So I'm going to put the center point at the L. Okay, I'm going to line it up with 0. Okay, do take your time to make sure it's lined up. All right, now here's 0. Okay, I want to use the inside because that's where my angle is pointing. Okay, I'm calling this the 0 side of the angle. So I want the part that's 0. Okay, going this way. So 0. Okay, this side's 180. I'm saying this is 0. Okay, it's where this angle is going to start opening. So it's 0, and I'm going to go to 82. Well, on a protractor, we go 80, and then each little line is worth 1. Each tick mark is worth 1. In between the two 10s is a 5. So here's 85, 84, 83, 82. So you're going to put a dot at 82. Okay, and then we're going to connect the dots or the points. And this is point K. That's an 82-degree angle. Does that make sense? Well, 82 degrees is less than a right angle. This angle, if you remember our corner pieces when we had our folded paper, remember the corner of a page is a right angle. Well, if I was making a right angle, it would be going straight up this way. So this is less than a right angle, so it's reasonable. Okay, 82 is not much less than 90, and that's pretty close to 90. Okay, so let's move on. And it wants you now to measure angle ABC. Place the center of the protractor on the point. Okay, so now this one here BC is the 0 ray. Place the center of the protractor on point B, okay, right here. Align ray BC with 0 degrees. Read where angle BA, or ray AB, intersects the same scale. Okay, so let's put this on here. I've lined up my 0. Now I'm going to extend A out. Okay, A, and I'm going to use the outside, because we said this is the 0, right? So I want the outside scale with the 0. So I keep going across till it crosses, and it looks like it crosses exactly in the middle of 60 and 70, so 65 degrees. And I was obviously showing you if I was just measuring it, they'd have the protractor already here for us. And we do see that it goes through 60 and 70, so 65. Okay. Now, number 2, use a protractor to find the angle measure. All right, so we're going to put the center point of our protractor on point N. That's the vertex of the angle. We're going to line ray NM at 0, and then use the same scale to measure where ray NO crosses the protractor. I'm going to extend my ray out. Okay, line it up with 0. Okay, I'm going to use the inside scale because that's 0, and it crosses at 50, 55, 56, 57, 57. We're to double check. I didn't draw my line out long enough. So let's try that again. Fifty-five, 50, 56, 57 degrees. Call it 56 degrees. TSR. And I'm going to line 0 up with point S. I'm going to line up my protractor at 0. I'm going to use the outside scale and find where it crosses. It crosses at 102. Let's see, 100. I'm a little high on this. 103 degrees. Okay, so let me show you again. Okay, so we've lined it up. Put the center point on point S. We have this ray that points at 0, and then we're going to go around until ray ST crosses the protractor. Crosses at 100, 101, 2, 3. At 103 degrees. Use a protractor to draw the angle. 170 degrees. Well, that's almost a straight line, right? A straight angle. 180 is a straight angle. So let's draw. It doesn't have any points, so I guess we can name it anything we want. So I guess I'm going to call that point A, call this point B. Okay. And then we want to find 180 degrees. 170 degrees. So line your point of your center point up at A. Line your ray at 0 and go around until you get to 170. Oh, 170 is actually off of my paper. I guess that's partially the problem then. Okay. Try to show you on here. And then you can, it didn't give you much space to draw that on your paper. All right. So again, I'm going to call this point A, point B. Okay. Line up A. Line up ray AB at 0. Trace it, go around the same scale until you get to 170. 170 is right there. That's going to be point C, and then join your points. So that would be 170 degrees. And that makes sense because, again, a straight angle would be 180. So that's almost a straight angle. All right, let's try 78 degrees. Okay, I think we can do 78 on our paper here, on the book easily. Okay, so okay, so EF, ray EF, I'm going to line it up with 0. Okay, and then we have to find angle 78 degrees. So 0, 10, 20, 30, 40, 50, 60, 70, 75, 76, 77, 78. And we'll call that point D. Right. So that is a 78 degree angle. It does make sense. It's slightly less than a 90 degree. It's slightly less than a right angle. So that would work. Okay, page 451. Use a protractor to find the angle measure. Okay, well, remember the blue symbol means it's a right angle. A right angle has to be 90 degrees. But let's practice using the protractor to prove that it's 90 degrees. Okay. All right, so if you got it lined up at 0, I put the center point at R. I lined up ray RS at 0. And I see where it crosses. And if I extend the line up, it would cross right at 90. Okay. See that it crosses through angle 90 degrees. Okay, so QRS measures 90 degrees. Okay, number 7. This is going to be greater than a right angle. Okay. And it's less than a straight angle, so it's going to be somewhere between 90 and 180. This time the ray is pointing this way, so this is going to be my 0 side going this way. So I'm going to put the center point on Y. I'm going to line up ray YX with the 0, and I'm going to see where it crosses. I want to extend this ray. All right, now, where does it cross our line? We're using the outside scale. So 0 is crossing at about 151 degrees. Let me look closely, make sure I'm lined up. Okay, I'm not. Okay. Actually, it's at 51, 52, 53. 153 degrees. All right, use protractor to draw an angle that's 115 degrees. Okay, I think I'm going to go this way this time. And I don't know, let's call it WX, XWY. So put the center point on W. Make sure it's lined up with 0. Okay, we're going to use the outside part of the scale. Okay, and we are going to go to 115. So here's 110. Halfway in between 110 and 120 is 115. Okay, and we're going to call that Y. We'll connect it. All right, that's greater than a 90-degree angle. 90 would be like this. It's less than a straight angle, so it's reasonable. 67 degrees. That's going to be less than a right angle. It's an acute angle. So I'm going to go this way to the right. That'll be my 0 ray. And I'm going to call it A, B, and then angle C. So angle C, and it has to cross at 67 degrees. So use the inside scale. The ray is pointing this way. So 0, 60, 65, 66, 67. So angle ABC, 67 degrees. And number 10, draw an example of each. Label the angle with its measure, an acute angle. All right, so anything less than a right angle but greater than 0 is a acute angle. X, Y, Z. So put Y in the center point, line up the ray with 0, And I don't know, I'm going to make mine a 20-degree angle. We'll call that Z. Label the angle with its measure. Okay, so measure of angle X, Y, Z equals 20 degrees. An obtuse angle has to be greater than a 90-degree angle. Okay, so if my angle opens this way, and we can call this D, E, and the point that is going to cross angle ray EF, and it is an obtuse angle. So anything greater than 90 degrees is an obtuse angle. So I'm going to put mine right there at 100 degrees. Confirm it. Yep, 100 degrees. So a measure of angle DEF equals 100 degrees. Number 12, a straight angle. Okay, don't put too much thought in that one. That's just a straight line, right? So put your point at 0, put another point at 180, and draw a straight line. Connect them. QRS. Measure of angle QRS equals 180 degrees. Okay, so it still has a vertex. These are the two rays RQ and ray RS. Draw an angle with a measure of 0 degrees. Describe your drawing. 0 degrees. What do you think? What would a 0-degree angle look like? Well, okay. If I put this there and I draw a ray this way, it hasn't opened. So it has to be 0, right? Because we've been saying that we're going to put this ray, line it up with 0. Okay, so the other ray is actually sitting on top of it. It hasn't opened. Okay, so okay. All right. So it doesn't appear like there's anything opening between the rays. So that has to be 0 degrees. If it moved just slightly, it would be 1 degree. Okay. There would be a slight gap between the rays at that point. If there's no gap between them, that has to be 0. 15. Hadley wants to divide this angle into 3 angles with equal measure. What will the measure of each angle be? Into 3 angles with equal measure. Well, right now, this is a 90-degree angle, right? But we want 3 angles. So how can you divide a 90-degree angle by 3? I can put 3 tens in 3 groups into 3 groups with nothing left over. Bring down the 0 ones, 30. So we want 3 angles that measure 30 degrees. All right, so put your 0, your center point at U. Line up this first ray at 0. Use this scale and go across till you get, back for a second. Thought I was going crazy there for a second. Okay, 0, and then go across until you find 30. 30 is right there. So we're going to line up our straight edge of the protractor. Okay, that's 30 degrees. Now we need to go I'm doing that more worse than I have to, but it's good practice. Okay, if we add another, if we start with this point now, we want to go 30 degrees from that angle. So there's 0. Here's the 30 mark again. Connect them. And now we have 3 equal sections of 30. 30, 30, 30. Okay, Tracy measured an angle as 50 degrees. That was actually 130 degrees. Explain her error. Well, okay, so if I look at the protractor, I notice that 50 and 130 are in the same spot. She says she measured an angle as 50 degrees. That was actually 30 degrees. She didn't use the same scale as 0. She didn't use the correct scale. "17. Choose the word or number to complete a true statement about angle QRS." Okay, so when I look at angle QRS, I know it's greater than 90 degrees. So it cannot be an acute angle, and it cannot be a right angle. So it has to be obtuse. And so it can't be 45 degrees. It's got to be 115 or 135. So we're going to verify that by putting the center point on R, line up ray RQ, see where it extends. 0's on this side, so I'm going to use the inside scale, and it crosses in between 130 and 140, so 135. All right, 18 and 19. Earth revolves around the sun yearly. The northern hemisphere is the half of Earth that is north of the equator. Okay. The seasons of the year are due to the tilt of Earth's axis. Now use the diagrams and a protractor for 18 through 20. In the northern hemisphere, Earth's axis is tilted away from the sun on the first day of winter, which is often on December 21st. What is the measure of the marked angle on the first day of winter, the shortest day of the year? What is the measure of the marked angle on the first day of winter? All right. So we're going to line up the sun and Earth at 0. And we're going to see where it crosses. And it looks to be about 65 degrees. Oh, I was using the wrong side. Okay, if this is 0, right, I can't use the inside. I have to use the outside. So it goes all the way around. I think we need to extend this out. All right, so I'm at 0. It's crossing at, we're using the outside scale, crosses one mark past, I'm going to say 111 degrees. Okay. 19. Earth's axis is not tilted away from or toward the sun on the first days of spring and fall, which are often on March 20th and September 22nd. What is the measure of the marked angle of the first day of spring or fall? Okay, well, you can look at that, right? I see perpendicular lines, so that's going to be a 90-degree angle. But let's verify it. All right, so here's 0. The sun's lined up with 0. I'm going to use the outside scale, and it comes around, and it does line up with 90 degrees. Okay. So 90 degrees. Okay, guys, that's it for using a protractor to draw and read angles. Our next time we're going to meet together, we're going to be reviewing for the Chapter 11 mid-chapter checkpoint. So until then, may the numbers always be in your favor.